So for our lesson for today, our content objective is I will be able to factor quadratic expressions in the form of ax squared plus bx plus c, and when a is equal to 1. So we're talking about this a term here. We're also going to talk about our language objective. I will read each problem and write my factors of the quadratic expression that are given. So that's what we're going to focus on today. So what we want to focus on is basically our standard form. So standard form of quadratics is always in this descending power order of whatever my a coefficient is, x squared, plus whatever my b coefficient is, x, plus some sort of constant here. So what we're talking about is my coefficients. This could stand for 1, this b could be a -4, and this c could be a +4. And we want to make sure we label these because these three variables are very important for our lesson for today. So a is always the one in front of the x squared, b is always from the one in front of the x, and c is always our constant term without a variable. So what we're going to practice on is rewriting our equation in this standard form. So always your x squared has to go first. So if I take a look at this one, I have 14 plus x squared plus 9x. I want to rewrite that in standard form. So this is what it looks like. X squared goes first, so it's positive. Start down x squared. Next one follows is my bx, or my 9x here. So I have a plus 9x, so plus 9x. And then I have this 14. Now, if I don't see the sign here, so I know it's a positive, so I put a plus 14 just to put it in my standard form, just like this. Now, I have to identify A, B, and C. Once you have it in standard form, it's pretty easy from here. So what's going to happen is there's an understood invisible 1 sitting up here. That is our 1. Okay. Now my B term, I'm going to put in, the same colors here. That's my B term. I will have a 9. My C term, our constant term, is a positive 14. So my C term is 14. So that way it's easy to label. And this is very important for our quadratic formula and also for our later strategies today. So let's go ahead and practice. So I gave you guys 3 problems. I want you to rewrite the equation here. Rewrite it here for each one, and then also identify what the A, B, and C are for each standard form of our quadratic formula. So pause the video real quick, try it before we start, and then you guys can check your answers afterwards. Okay, so cool. You guys just pause the video. Now I want to show you how to set this up. So the first thing, x squared is our leading term. So I got x squared. 4x is my b term, so I have to put my positive 4x, and here's my c term, my -5. So that's basically our first one here. So my a number is 1, my b number is the 4, and my c number is -5. Now let's take a look at the second one. Second one, I got to put my x squared first, so I'm going to drag this to the front, so x squared. My b term is the one with the x, so positive 7x, and my 10 is a positive 10. So let's go ahead and label our a, b, and c. A is again 1, B is 7, C is 10. And then the last and final one. So again, rewriting my x squared up front, it's positive, so I leave it as a positive up here. Now I find my b term, and how do I know which one's b? It's the one with just the x. So that's a negative or -5x here, so I'm going to put -5x. And then I look around, and then here's my constant term. I know it's a constant because no variable, and it's a -6 as well. Let's go ahead and label our A, B, and C's. A is going to be 1 again. B is going to be a -5 because in front of this x is single variable of x. And then my constant term of -6. And that's what we're doing when we're talking about writing in standard form. Now, why is that important? So what's important is basically I want to make sure it's factorable. So basically I want to make sure that it's in that proper form. So the very first step, what we're going to talk about is making sure, is it in the right form? I have my x squared plus my b, and then here's my x, plus that constant term. So it's already in standard form. We're good to go. So what we're going to look at today are these 2 different methods. Reverse box method refers to what we've been doing lately, but going in the opposite order. Diamond method, and they call it diamond because basically it's like this little diamond X method is what we're going to use for today to help us do the reverse. So basically what we talked about this week was taking these factors and doing the box method or multiplying. Now we're going to work backwards, and I'm going to show you guys those steps and those strategies today. So the very first thing is, if I'm doing that reverse box method, you got to make your box first. And how it works, and basically you're setting this up, same kind of concept. these two terms, let me try a different color. So these two terms here, they don't change. Okay, so when we were multiplying it out, notice how we were always combining the ones in the middle, or you were combining the ones that were diagonal, depending on what method you use. But we noticed that these two never change as far as our answer. So we want to type in your leading term here. So for this one, I want to put in my x squared, and then the ending term, so type in your ending term here, and that's my positive 15. So we have to figure out what these two are in order to make this, work and work backwards to figure out these parts of what we put on the outside. So the easiest way to do that is, again, taking your A and C. And this is why the A and C is important, because now I got to look at what is my A. So my A equals 1. What is my C? Well, C equals 15. Okay, so what we're doing now is I'm going to just take my A times C. So 1 times 15, well, I just get 15. What are the factors of this particular number here? So now I got to figure out what numbers can multiply to give me 15. Well, 1 times 15 gives me 15. 2, 3, and then 3 times 5 gives me 15. And those are basically all the factors of 15. What we're going to do next, and this is the important step, is out of these combinations, which one can equal to this middle number 8? So we're trying to figure out if I add or subtract, which one can give me 8. So I got 1 and 15. Can I ever get an 8 possibly by adding and subtracting these two numbers? No. So that won't work. 3 and 5, that could work. 3 plus 5 can definitely give us our 8. So this one's going to work for us. So what's going to happen is now I know what these factors are. So I'm going to put it as, and it doesn't matter which one where you put it. You can put the 5 up here or the 5 down here. But we're going to work backwards with this. So I'm going to put my 3x. And basically, remember, we got to have our x's because that's 8x. So 3x plus this 5x. And then if I were to work backwards and I do that, when we were multiplying, we would take these two terms and add them. I would have my 8x back what I have here. Now, we have to apply our GCF working backwards. What number, if I'm going from this way, so these two blocks down here, what number can I factor out of 5x and 15? Yeah, so the number I have in common is a 5. I can take 5 out of this. I can take 5 out of this one, and it's going to leave over a term. So the whole point is you guys working backwards to figure out what is that other term. Here, I don't have that leading number like how I did in that last example. So now I can't take out a number, but look at the x's. They both have an x in common. So I have two x's here, or x squared, and then I have an x here. So I can take out one x from each one, and I have this little setup here. So I have an x and a 5, a positive 5 here. Now let's look at the top. What can I factor out of each one? So I have an x squared, I have a 5. They don't have any common numbers here, but they do have that x again. So I can factor out an x. I can take one x from here, and I can take one x from this one, and that's what we're doing here. If you look, so kind of working backwards, x times x, well, that's x squared. 5 times x, well, that's 5x, and you're constantly checking to make sure that's right. So if I go to this one, what can I factor out of each one? I have a 3, I have a 15. So I can take 3 out of this. Can I take 3 out of 15? Yeah, and I'll be left with 5. So what's going to happen is I'm going to factor out a 3 from each one, and then double check and make sure it works. If I go x and 3, I get 3x. If I go 5 and 3, I get 15. And so these are our factors on the side, and this is how you get that factor form of, working backwards here. So I have one where it's x, and that's positive, by the way. So x plus 3 is that one binomial that we had, and my other one's x plus 5. And that's our factor form. So x plus 3 times our x plus 5, and that's our problem here, our factor form from this working backwards using the box method. Diamond method. Diamond method is very similar. The only difference is just how it's set up. You're doing the same thing, except most of your work is setting up here. So basically, in other words, I take my A and C. So A and C, I look at my A and C. So again, A is 1, C is 15, and I do that same process here. So this part really doesn't change. My factors of 15, 1 and 15, 3 and 5. The only difference is now I take that A and C number and I place it up here. What is my B number? So remember, this is A, this is B, and this is C, kind of what we're doing here. And my B number is 8. You're trying to figure out from this list what numbers can multiply to give me 15, but add or subtract to give me 8. So if I multiply these two, I get 15, but when I add or subtract these, I can't get 8. The only ones that work are these two. I have my 3 here. I have my 5 here. So what happens is basically if I do 3 times 5, I get 15. Since they're both positive, if I do 3 plus 5, I get my 8. So basically these are my two factors I'm going to have. And because of our setup, because of how it's set up here, since this is just x squared or a is equal 1 where it's all by itself, I can simply split these apart and have it this way. I can just drop this x down and separate it into 1x and 2x. So I have my x squareds here. And then I basically take these, since these have no signs, I know that's positive. That was positive to make this work. And that's how we factor it using this little diamond method.